Well, today we're going to talk about what an ellipse is and how you go about graphing it. And what I want to recall for a minute is the equation of a circle. And this is a circle with a center at the origin, just like this ellipse is. The equation of a circle is x squared plus y squared equals r squared. But what I want to show you is if you divide r squared on this side by r squared, you're going to get x squared over r squared plus y squared over r squared equals 1. Now, what this is saying is the second equation here, this is in the same form as the equation of an ellipse, and in fact, a circle is a special type of an ellipse. Notice an ellipse, like a circle, they're closed shape. We've got a center, but an ellipse has something that the parabola has, and that's a focus. In fact, an ellipse has two foci. Let's say we've got one here and one here. So these red dots here represent what we call the foci, and then I'll show you that we also just refer to that as the C distance, but I'm getting ahead of myself. Another thing to look at with an ellipse is that it has what's called a major axis, and that is this dotted line that's running lengthwise. I'm going from the longest side to the longest side. So that's the major axis. So let's say that this is major, M-A-J-O-R. That's the major axis. And then this guy right here, that's the minor axis. And that's the minor axis. Now, along the major axis, we have a, let me change colors, we have a vertex here and here. And then we also have a minor vertex here and here. So we have a minor vertex. I've also seen it referred to as a covertex. But anyway, they go with the minor axis, and then you've got your vertex or vertices with the major axis. Okay, I think that's really about all we need to look at. So let's go ahead and look at exactly what happens with an equation and how we graph it. So I'm going to erase all this and delete this. I'll just move it out of the way. Well, maybe I won't do it. There we go. Okay, so we've got this equation. We're going to graph and we're going to locate the foci. So here's what's going on. The equation of an ellipse is x squared over a squared plus y squared over b squared equals 1. This is a horizontal ellipse because our a is underneath the x, or a squared is underneath the x. Now, another way that we show it is like this. This time, the a squared is underneath the y, and the b squared is underneath the x. So this guy gives us a horizontal ellipse. This guy gives us a vertical ellipse. Alright, so let's look at this. I've got my equation, x squared over 9 plus y squared over 4 equals 1. So my bigger number, 9, is a squared. A squared is always the bigger number. So a squared is 9. B squared is 4. If a squared is 9, then a is going to equal 3. And if b squared is 4, then b is going to equal 2. And that's a 3. Okay. So I've got what a is, I've got what b is. Now, I've got to figure out what's c. And in a minute, I'll put all this together for you. The formula to find c or c squared, is c squared equals a squared minus b squared. So c squared equals 9 minus 4. So c squared equals 5, and c equals the square root of 5, which is approximately 2.1 or so. Now I've got enough information here to graph this. I know that I'm centered at the origin because I don't have any h and k going on, and of course that's what we'll do tomorrow. But just want to get that out of the way. So I know I'm going to start at the center. My center is at 0, 0. Now, my bigger number, my a squared, is with my x, so I know that this is a horizontal ellipse. My a distance is 3, so I do a distance of 3 from my center and put my points. Now my b distance is 2, so I go from my center and put my distance of 2. And then I'm going to do my best to draw an ellipse. And I've been told they look like lemons or footballs or whatever, and they're not that great. But that's what it looks like. Now the last thing what I have to do is I have to locate my foci. Well, my foci is this distance right here. And that's about 2.1. So I go, and I'm just estimating here, 2.1, negative 2.1, and then I'm going to label it. 2.1 is the square root of 5, or 2.1 is approximately the square root of 5. So the location of this red dot is the square root of 5, comma, 0, and this one is the negative square root of 5, comma, 0. There we go. I graphed that ellipse. So let's look at another example. Okay, we've got x squared over 36 plus y squared over 9 equals 1. So what I have to identify is what's a squared, what's b squared, and what's c squared. And a squared is always going to be my bigger number with an ellipse. So it's 36, which means b squared is 9. And then c squared is 36. Well, you can't read that. C squared is 36 minus 9, which is 27, and C then would be the square root of 27, and I need to put that as both positive and negative. So C equals plus or minus the square root of 27, which is approximately 5.2. Alright, I know I'm at the center because, like I said, I don't have h and k to deal with. So I start here at my center. My, A is going to be 6, B is going to be 3. So I go 6, and I go 6. I'm going 3, and I'm going 3, and I'm going to draw this guy like that, and then I want to mark where my foci are, and they're at 5.2, which is about here and here. This is a distance from the center of 5.2. I'm not really paying attention to negative signs because distance isn't negative. I'm just starting here at the center and I'm going whatever distance my A, B, and C tell me to go. And now what I'm going to do is just go ahead and make note of what this point is. So that's the square root of 27, and I'm 27, comma 0, and this is the negative square root of 27, comma 0. Alright, so the last two examples, they've both been horizontal. Let me show you what a vertical looks like. we've got, let's call this one 1, call this one 2. So in equation 1, we're going to figure out what's a squared, what's b squared, what's c squared. A squared is 36 because it's the bigger number. So that means a is going to be 6. B squared is 9. So b is 3. And c squared is 36 minus 9. Because remember, it's c squared equals a squared minus b squared. That's the way we find c squared for an ellipse. And 36 minus 9 is 27, just like it was in the last time. And so c is the square root of 27. And again, we're looking at the positive and negative square root of 27. And we got enough to graph it. Remember, our a squared this time is underneath the y, so we're going to be going 6 units here on my y-axis, 6 units down, and then my b is 3, 3, and then I'm going at 5.2, and I'm just estimating that focus, and that is going to be at 0 square root 27, and that's going to be at 0 negative square root 27. And these numbers have to refer to our foci because we have to label our foci. So we could say foci, draw a picture, point an arrow, whatever you need to do. But anyway, you need to label it, that's the foci. So let's look at number 2. And I'll erase that. So this time, I've got to find out again, a squared, b squared, c squared. A squared is 49, again it's the biggest number, so that means, whoops, that's a equals 7, 7. B squared is 49, b squared is 16, so b equals 4, and c squared is 49 minus 16, which is 33, and c is the square root of 33, which is what? Less than 7, less than 6, it's like 5.7, 5.8, something like that. Let's see, second square root 33, 5.7, approximately 5.7. So I know I've got everything I need to graph it. I'm going to go here with my a, which is at 7, negative 7. I've got my b at 4, negative 4. And I'm going to plot my c at 5.7, so that's like right there maybe. And we're estimating our foci, so that's why we go ahead and label it so we know that we know what we're doing. So this is again 0 square root 33. This time this is at 0 negative square root 33. Okay, what else? This time, let's see what happens here. We've got this situation where we have to get this equation into our standard form. Well, remember we had it, our formula was x squared over a squared plus y squared over b squared equals 1. Well, in this case, it doesn't equal 1, it equals 400. So to make it equal 1, we divide by 400. And if we do it on one side, we've got to do it everywhere. And now we simplify these fractions. So 25 over 400 is actually 1 over 16. So I'm going to write x squared over 16 plus, and this is going to be 16 over 400, which is 1 over 25. And then that's going to equal 1 because 400 over 400 is 1. So now I've got a squared and I've got b squared. And I need to figure out what c squared, so a squared is 25, b squared is 16, 25 minus 16 is 9, so a is what? 5, b is 4, c is 3. So now we plot it. Bigger number under the y, I go to my 5, I go to my 5, I'm going here to 4 and here to 4, and I'm going to draw an awful looking ellipse, and now my c is at 3, so I go here to 3 and here to 3, and then say, okay, this is 0, 3, this is 0, negative 3. And that's all there is to it. So what else? Okay, and this time we're given the location of the foci and the vertices, and we have to come up with our equation. And that's supposed to be a comma there and a comma there. So look at this. I always just go and plot it because it helps me see what's going on. I know my foci are going to be at negative 1, 0, and negative 1, 0, and 1, 0. And then my vertices are going to be at negative 2, 0, and 2, 0. So that's here and here. So I need to ask myself, okay, what's a squared, what's b squared, what's c squared, and then what's a, b, and c? Okay, a is the distance from the center to the vertex. Well, that's 1, 2. So a equals 2. B, no clue what it is. C, from 0 to 1. So c is 1. Well, if c is 1, c squared's got to be 1. If a is 2, a squared has to be 4. And we know that c squared equals a squared minus b squared. So c squared equals, whoops, that's not right. C squared is 1. So 1 equals 4 minus b squared. So what do? Subtract 4 from both sides. And get negative 3 equals negative b squared. And if negative 3 is negative b squared, then 3 equals b squared. So I've got what b squared is. Well, that's 3. b is the square root of 3. So I've got all the information I need now to write my standard form of the equation. Remember, it's x squared over, well, let's see, is it over a squared or b squared? Well, do you see here that the foci are on the same line with the vertex, or the vertices, I should say? So that means that they're on this major axis. Since they're on this major axis, that means that it's horizontal, right? So that's under x. So my a goes under the x. So I have, or a squared goes under the x. So I have x squared plus, nope, stop, x squared over 4 plus y squared over b squared equals 1. That's all I need right there. Okay, thanks for watching.